Hello everybody, this is Mr. Bowman. So today we're going to be looking at the ALEKS topic, identifying transformations that map a regular polygon onto itself. So this time we have an equilateral triangle. That's going to be important here. So all the sides are the same size. Line C passes through a vertex and bisects this side, so perfectly cutting that bottom part in half. Line D bisects each side, so cutting these sides in half lengthwise. So the length on here and the length on here are the same. And point Y is the center of the triangle. Okay, since it's an equilateral triangle, that actually means something, but you may remember that there's actually a bunch of different types of centers of triangles. There's circumcenters, incenters, and all that kind of stuff, but they're all the same for an equilateral triangle, so I'll buy that. All right, so which transformations must map the triangle exactly onto itself? A counterclockwise rotation about Y by 72 degrees. So if I rotate 72 degrees, is that going to work? Well, I don't know. So let's look at where our symmetries lie and what rotational symmetries we might have. So the trick with this is figure out, if I imagine this as like a knob on a door, how can I turn it so it lands the same way? So think about it as I need to turn it so the point's down. So this one could be down, or if I rotate it a little bit, this one could be down, or rotate it more, this one could be down. So there's really three kind of orientations for this triangle. They could be down. So in order to figure out my angle of rotation, I'm going to take my total 360 degrees of rotating it all the way, divide by how many there are, in this case 3, and my only rotational symmetries are 120 degrees. So this 72 degrees isn't going to work, and this 216 is not going to work either. So both of those are out. Reflection across C. So if I take these two parts and kind of use this, imagine as almost like a string here, and I spin it so it flips over, will it land in the exact same orientation? And the answer is yes, actually, for that one. What about D? If I take my string and spin it this way? No, actually, because we have a smaller triangle on this side as opposed to this sort of trapezoid on this side. So if I flip those around, the trapezoid would be over here and the triangle would be over here. So that is not going to work. So reflection across line C is the only one that will work for this one.